In this video, we are going to talk about equation of continuity. But before talking about equation of continuity, we have to understand certain other things for understanding equation of continuity, how we can drive this equation of continuity. Here, basically, we will be dealing with ideal fluid. Your fluid is ideal. What do you mean by ideal fluid? Ideal fluid means it should have steady flow. Then it should be incompressible fluid. Incompressible flow. And another thing is it should be non-viscous flow. And another thing is it should be irrotational flow. Means our flow conditions should abide by these four laws. Should be steady flow, incompressible flow, non-viscous flow, and irrotational flow. What do we mean by steady flow? Let us take steady flow means suppose a fluid particle is moving like this. You have a pipe. Then at this point, suppose point P is there. At any given point, the velocity of the moving fluid at P does not change with time. Means any fluid particle, if it is coming on this point P, then the velocity should not change. It should remain constant at a given time. Like this, suppose this is another point, then at this point it should have a constant velocity at a given time. So this is called steady flow. Steady flow is also called laminar flow. Means the flow is moving in laminas, in layers. Correct? What about incompressible flow? Incompressible flow means the density of the fluid particles should remain constant. Non-viscous flow means it should not have any friction between the layers. Like one particle is moving like this, another particle is just adjacent to it, it is moving like this. Then they are in close proximity and they should not have any friction in between. Otherwise, flow conditions will change. In practice, it is not so, but ideally, we are assuming that it is a non-viscous flow. Irrotational flow means the fluid particles should not rotate along with the flow. So let us see what it means. Basically, basic important thing is steady flow. Means if every particle is moving in a streamline. These are called streamlines. Suppose this is the pipe. Inside this pipe, these fluid particles are moving in streamlines. So these are called streamlines. Streamlines, according to the shape, streamlines can be like this also. Correct? At any point, tangent to this curve will give you velocity of the fluid particle. So this is a typical streamline. Correct? The flow is moving in laminas. Now, let us see here. Suppose you have some obstacle, then how you can draw the stream. These curves have to be very smooth. And at any point, tangent to the curve will give you the velocity at that point of the streamlines. So this is basically something about streamlines, laminar flow, and how an ideal fluid behaves or how an ideal fluid flows. Now, with this concept, let us say, suppose you have an opening like this. This is point P, this is point Q, and this is point R. These are the streamlines going in this file. So, suppose in delta T time, what will be the mass flow inside this? It will be omega. Sorry, what will be the mass flow? It will be rho. Then area of this, suppose that is AP. Then if velocity is here Vp in delta T time, it is per unit time. This mass will flow up to this distance, Vp into delta T. So rho AP into AP into Vp into delta T will give you the mass flow in delta T time through P. Suppose here the density of the liquid is rho P, then it must be equal to, because whatever mass is going inside through this opening, it will reach there at Q point, and it should be the same. Where AQ is the area at Q point, then at Q point VQ is the velocity, and again it is now coming out from R. These all should be equal. So basic idea is whatever mass is going inside, it is coming out. The same thing is coming out from this tube, correct? But since the fluid is incompressible, so rho P must be equal to rho Q and rho R. That means what will be left? AP Vp is equal to AP AQ VQ is equal to AR into VR. That means area into velocity. This product remains same at any point in the tube, and this is called equation of continuity. So you can, in simple terms, V1 A1 must be equal to V2 A2. This is your equation of continuity. So product of velocity and area, this remains constant at each point in the pipe or whatever is there where the liquid is flowing. And what is this? A into V, this is nothing but volume flow rate. Now, rho into A into V, what it will be basically? It will be mass flow rate. So, this is our equation of continuity. A into V gives you volume flow rate, means volume flow rate at any point inside the pipe or tube or whatever it is remains constant, and mass flow rate is rho into A into V, that also remains constant. Suppose you have a tube like this, where it is A1, V1, here it is A2. So here you can find out V2 with this equation very easily. So this is the one, this is the meaning of this. I hope you understood this.